Hey there, can you believe it? It's already the last unit of week 2. We're right in the middle of our course from media computation to data science. And just look back of where we stand now. We've learned how to take apart media into its building blocks, cut out the things, the elements that media is made of. So we work with these building blocks. And we learned the building blocks are numbers. So we can take these numbers and combine them into new media by sticking them together and turning them into new entities. Yesterday, Yadka has shown you how to generate sounds, totally new sounds, out of numbers. And today, we're going to take this one step further and actually compute a picture. Let's have a little look at how pictures are made, what pictures are made of. I'm going to start by drawing a costume, and it's just going to have some very basic colors, like here's a red square, there's going to be a blue square, and a green square. And I'm going to make a sprite and have that sprite be over that red square. So now in the sensing block, we've already shown you the at block that lets us get a hue at a certain location. So we're going to take that and we can get the hue at myself, which is the tip of the sprite, and the hue is some color. And there are other options we've already looked at, like there's the saturation, the brightness, and the transparency. But look at the bottom, there's something new you haven't seen yet. It says RGBA. So let's see what happens when we choose RGBA and click on it. We get a list of 4 items and some, you guessed it, numbers in there. Now, it says RGBA because this is an abbreviation for what we call the color channels. R stands for red, G for green, B for blue, and A for alpha, which is another word for translucency, transparency. Colors in pixels and photos are made up of these 3 color channels because those resemble the receptors in our own eyes. We can also look at that picture. We go back to the sprite, go to this category, and choose the current costume. We can look at the pixels of the current costume. Now, if we look at the pixels of the current costume, we get a table. And ever since we generated music and a song using a table, you know that a table really is a list of lists. So here I have a list of 4,056 rows and 4 columns, and they're mostly the same colors, but they change. So here you can see that the first channel is all the reds, the second is all the greens, and the third one is all the blues. So what if it's just a list of lists of numbers? We should be able to make our own one, right? Let's try that. And I don't know if you realize this. This really is some heavy-duty crafting, some engineering. And that's, where I'm going to wear my safety goggles for some heavy-duty engineering, because this is the real stuff that only hardcore programmers do. Let's make a new project, and let's program a color gradient, okay? So I'm going to make a variable that is called pixels, and I'm going to set that variable to a new list. And now what I want to do is I want to make a color gradient that starts off blue and then gradually turns to red. So I'll take the for loop to get the numbers, and I start with the number 0 and go all the way to the number 255, because that's how color channels are encoded. The hue, saturation, brightness model encodes colors on a scale of 1 to 100, but the pixels and photos you take are encoded in a scale of 0 to 255. So I'm going all that scale, and what I'm going to do is I'm going to add I to that pixels list, and I'm going to make this very fast. I'm going to wrap a warp block around this, and then I want to look at the result of this. So I'm going to report the pixels. So when I click this now, I get a list of 256 items, starting with 0 and going all the way to 255. Now what we need is a list of lists. So instead of I'm going to put in a list here, and that list needs 4 items for red, green, blue, and alpha. So I'm going to expand this to 4 slots, and I'm going to put I into the first one, which is the red slot. It's going to start at 0 red amount and going all the way to full red amount. The second slot really can be anything. I'm going to put in 60, and that's just by trial and error because I've been wearing these goggles for so long. I've tried a bunch of things. The third channel is the blue channel, and I wanted to do the inverse of the first channel, which is I'm going to start with 255, and I'm going to subtract whichever value I is. Now the fourth channel is transparency, and I don't want any of this to be transparent, so I'm going to put it at 100% at the value of 255 all the time. Let's check this out. See, I'm getting a table, and you can see how these both channels, these columns, kind of do the inverse. One increments, whereas the other decrements. So what do I have now? Now I have a single row of pixels. In order to actually see this, I need it to be also to have 2 dimensions. So I need several rows of pixels. So I'm going to actually just repeat this 10 times. Now I have very many pixels, like 2,500 pixels already. And now it's time for the magic. Now I want to take this table and turn it into an actual picture. So, good news, there's a block for that in Snap. It's in the looks category. And it says new costume. Remember, costumes is what we call pictures in Snap. So I want to report a new costume, and it takes the pixels as its first argument, and I can then specify the dimensions of that new costume. Now the dimensions are, I want it to be 10 pixels wide, this is the repeat 10 block, and 256 pixels in its x direction. Let's try this and see what happens when I click this now. Wow. This is kind of the wrong way. I said it right, but I wrote it wrong. I want it to be 10 pixels high and 256 pixels wide. Now let's try it. We're getting a picture, and we can already see that there is a gradient from blue to red in there. You know what? Since this is a costume, we can make the sprite wear it. So instead of reporting it for me to see, what I'm going to do is I'm going to directly switch to that costume. And now check out what's happening to the sprite. Wow. Now I just wrote myself some code that made a new costume, that made a new graphic. And this is really all the magic there is. See, we can take media apart to numbers, we can do something to the numbers, but we can also generate perfectly legitimate media just out of numbers, out of computations. So now we've got this gradient, and let's see what else we could do with it. First, I'm going to make it a little bigger. I'm going to set its size to, say, 100%. And I'd like to turn this into an interactive widget, into a slider. Kind of thinking that this could be cold and this could be warm. And I'd like this to be on a scale of, say, 0 to 100. So I'm going to rename this to gradient. And I'm going to make a new sprite. This one's blue. I don't want it to be blue. So I go to the pen category and choose another color for it. I like white. I'm going to make it a little bigger by changing its size. And I can turn it around, rotating it so it points downwards. Now I'd like this to be a slider that I can move on this axis and see the redness underneath it. So I'm going to rename this to slider. I'm going to make it undraggable, and whenever the mouse is down, I want it to follow the mouse, but only on the x-axis. You might remember a script that is similar like that. Go to the control category, take out the when I am hat block. Again, choose when I'm pressed. Remember when we made the magic lens follow the mouse along? Same idea here. So again, we're going to repeat until the mouse is released, which is until the mouse is not down. And instead of going to where the mouse pointer is, we're just going to set the X position to the mouse X position. Let's try this already. So this already works, and if I move the mouse up and down, it doesn't follow. And now what we want to do is we actually want the slider to tell us a number, and the number should be which percentage the color underneath is. So I'm going to go to the variables and make a variable for this slider only. It's going to be a new variable. It's going to be value. And the value is going to be for this sprite only, which is only going to be a property of the slider. Now, if I click this, I get a new variable called value, and it's got a location pin here. This indicates that it's not a global variable. If I go to the gradient does not have that variable, but the slider does have it. It's also indicated here by having the name of the slider sprite in it. And whenever that mouse is moved, I want to set that value to the redness. Now, how do I get the redness? I showed you. We have the at block where we can get the color at something. We want to get the color at myself. I want to get the RGBA value at myself. Remember, this is the list. Now the redness is the first item. So we take the first item and we get the red value. Now, since that first item I told you is on a scale of 0 to 255, what we need to do is, we just need to divide it by 2.55 to get the percentage. By putting this in here, let's check this out. We get a nice scale from 1 all the way to 100, where our redness is. In order to make this a truly interactive widget, we want to be able for other objects, for other sprites, to react to changes of the slider. So we're again going to broadcast a message that others will be able to tune into. And I'm going to say broadcast the message called update again. So now, whenever we move the slider, the value is updated, but we want other sprites also to update. So what I'm going to do is, I'm going to move the slider down. Oh wait, there's one more thing. Actually, did you see, when I'm moving the slider down, when I move the gradient down, the slider stays up. Now I want this to be a single widget, so I want the slider to follow the gradient along. And here's the trick how we can accomplish that. We want to attach the slider to the gradient. Remember Yadga's example with the Ferris wheel? So we take the icon, move it over, so now the two are attached. And I can move it down, and I'm going to make the gradient undraggable, and now my slider again works. Now if I move one, the other will follow along. Let's make an object that reacts to this. So one idea was, this could be something, a simulation about global warming, about climate change. So we could represent this and draw a new object that would be the sea level. Let's draw the sea level. This is the sea. And here's the sea level. And we want the sea level to react to something. So whenever the sea level receives update, we could set its Y position to, and now we need to get the value of the slider. And we get that also in the sensing category with the off block. Here's the off block. We can choose the slider, and then we can choose the attributes of the slider. And at the bottom, underneath that bar, we have the value. The value is the value of that attribute. So now, as we move the slider to the left, the sea level sinks, but as the heat rises, the sea level rises. And this is how we can kind of turn this into a whole simulation of different things. For example, we could go to the stage and do the same thing for the background brightness. For example, we could change the background brightness and set that to, again, the value of the slider whenever we receive a message to update. And I'm going to hide the value of the slider. So now let's check this out. So now, as it gets warmer, the background also gets brighter. What we've done so far is we've generated our own picture out of numbers. We've learned about RGB colors, and we've made an interactive widget that other objects can react to. This is the basics you need to write really complex programs and to work with any kinds of media. And we're now right in the middle of our course, and this is going to take you along to the next week and gradually drifting into the realm of data science. I can't wait to see you next week.